This is lesson 86, probability of dependent events. Now, 85 was probability of independent events, events that do not affect each other. And these are events that do affect each other because you're drawing something out of a basket or your pocket or a bag of marbles and you don't put it back. So it's going to change what's left in the bag. We'll start off with one like number 1. It says a basket contains 6 apples and 5 peaches. You randomly select one piece of fruit and eat it. So we don't put it back like we did in 85. Then you randomly select another piece of fruit. The first piece of fruit is an apple, and the second piece is a peach. So we know we start with, and we know we're drawing one piece and then second piece, so we're actually drawing twice. It is an and situation, so it's multiplication. And we start out just like we normally did. How many pieces of fruit are in the basket? There are 6 and 5, which is 11. And I'm going to draw an apple out, I believe. The first one is an apple, and in the 11 pieces of fruit, there are 6 apples. So that's easy. You put it back as we did in 85, where it was independent, where taking that out did not affect the quantity or what's in the basket. But see, if I take a piece out and eat it, this now, I don't have 6 apples in the basket the second time. I only have 5 apples in the basket. So now my second draw has 10 pieces of fruit, and I want the second piece to be a peach. Well, of these 10 pieces of fruit, then 5 of them are peaches. Now, I like to cancel before I do the multiplication. To me, it's just a little bit easier. Your classwork is going to give the fraction and the decimal, and I believe you can probably just check it with the decimal. But it's good practice on reducing. I'm going to reduce the 5 and the 10 to 1/2, and then I'm going to cancel the 2 and the 6. End up with 3 times 1 over 11 times 1. Now, when I approximate that, and I think they're pretty consistent with 3 decimal places. There will be one that'll be 2, and you'll see why in just a minute. And this, you'll just have to watch your multiple choice. And then this one is about 0.273. Okay, let's go to number 5, because it's got a little bit of a different twist to it, and then we'll do some of the others. We're going to do 4 or 5 of these. There are 14 shirts in your closet, 5 blue, 5 green, and 4 red. You randomly select a different shirt each day. You wear a blue shirt on Monday, Tuesday, and Wednesday. You're going to draw a shirt each day. Now, you're not going to put it back in the closet dirty. You're going to wear it. You're going to go home, put it in the laundry basket, and so now there won't be 14 shirts in the closet. So we are going to be drawing Monday, Tuesday, and Wednesday, and I'm going to do it with the numbers just like I did in number 1. We have 14 shirts to choose from, and on Monday I'm going to wear a blue shirt. So let's look at our blue, and so we know 5 of the 14 are blue. I take the shirt, I wear it, I don't put it back in the closet, so now I have 4 blue shirts in the closet. So that changes my numbers. I now only have 13 shirts in the closet because I have 4 and 5 and 4. And it says I'm going to wear a blue shirt that day, but I only have 4 to choose from. See how my numbers went down here? Because we took one away, did not put it back, just like in 85. I keep referring back to that, but that's the difference, because a lot of times in an Algebra 2 or college algebra class, these are going to be mixed together. You'll have independent and dependent. So I try to clarify which one is different. Are you putting it back? Are you not? And then in the third day, now what's happened? We took one away, so now we only have 3 blue shirts, and we only have 12 shirts left in the closet, say 3 and 5 and 4. So there are 12 shirts to choose from, and only 3 of them are blue. Now again, I like to do some canceling. I'm going to cancel the 3 and the 12. I'm going to cancel the 4s. And I believe that's all I can cancel, because I've got 5 times 1 times 1 is 5. And I've got 14 times 13 times 1 is 182. And as a decimal, that's about 0.027. Okay, Let's go to, let's see. Let's go to number 2. Your sock drawer has 6 white socks. This is kind of an odd one. 6 white socks, 4 brown socks, and 2 black socks. You randomly pick a sock and put it on your left foot. You just reach in there and get a sock, and then you pick another sock and put it on your right foot. You don't care if they match or not. You leave the house with a white sock on your left foot and a brown sock on your right foot. Now, same situation. What are we drawing? 2 socks. Now, the first time we draw, how many socks are in the drawer? Well, they don't tell us, but we can add up. We've got 6 plus 4 plus 2, and there's 12 socks in the drawer. And it says we're going to put that sock on our left foot, and it says you're going to get a white sock. So, of the 12 socks, there are 6 of them that are white. Now, what's happened? You've now only have 11 socks because you took one of them out and put it on your foot, and you now only have 1 black sock. Is that what we drew? No, we drew a white sock, so we only have 5 white socks. So now we have 11 socks. We've got 5 and 4 and 2. You can tell that adds up to 11. And what does it say the success is? The success is a brown sock. So of these 11 socks that are left in here, 4 of them are brown. I'm going to do a little canceling. You can cancel the 6 and the 12. You could have canceled the 4 and the 12. We can now cancel the 2 and the 4. If you cancel it all, you multiply top and bottom. This is just good practice. And you get 1 times 2 is 2. And 1 times 11 is 11. And as a decimal, that's about 0.182. Okay, we're going to do a student problem, and then we're going to do a money problem. Oh, I kind of ran into the work here. There are 7 boys and 7 girls in a class, so there's 14 people to choose from. The teacher randomly selects 3 different students to answer questions. So let's make 3 fractions. Okay, we're going to start with 14, and she's going to ask a question. And now here's your biggie right here, 3 different students. So she's not going to call on the same person again. So it says the first one is a boy. So we know there were 7 boys. So she's got a 7 out of 14 chance. Now, she's not going to call on him again because it says she's going to do a different one every time. So now the boys have become 6. And how many students do I now have? 6 and 7 is 13. So of the 13 students, the second one is a girl. Now, how many of these 13 are girls? 7. 7 girls, 6 boys. So we've taken one of them away. So now we have 12 students. 6 and 6 give us 12. And we're going to choose another girl. So how many of these 12 are girls? And we notice that there are 6 girls now as we go down. So you have to watch as what your numbers are. You're going from a boy to a girl. The top number didn't change because there were 7 boys and 7 girls. But then the number went down here because, well, I think boy, girl, and then we're going to choose another girl. And then the number went down because we chose one of them here. I'm going to do again some reducing. And this is 1 times 7 times 1 is 7 over 13 times 2, I didn't show that canceling, is 26, and there's another 2. 2 times 13 times 2 is 52, and this is approximately 0.135. Okay. This one's very similar. It's money. You're taking the money out. Every time we're not including the previous situation, and that's why the number is going down on the bottom. There are 3 nickels, 4 dimes, and 3 quarters in your pocket. So how many coins do I have? 3 plus 4 is 7, plus 3 more is 10. I have 10 coins. We're going to draw 3 times. Now, and because you know you're not putting them back, you're putting them on the counter, you already know this is going to be 9 and this is going to be 8. Because when I take one away from this and put it on the counter, I only have 9 left in my pocket. And when I take one of these, I only have 8 left. Now, let's see what's affected on top. So the first 2 coins are dimes. So this one's going to be a dime, this one's going to be a dime, and this one's going to be a quarter. So of the 10 coins, the whole thing, 4 of them were dimes. I want this one to be a dime. Now, when we took one of these dimes out, we now only had 3, and we only had 9 coins. See, because we had 3 nickels, 3 dimes, and 3 quarters. And I want it to be a dime. So there's only 3 of the 9 coins are dimes. And after I took that one out, I now have 8 coins. We went from 10 to 9 to 8. And our dimes now went to 2. So we had 2 dimes, 3 nickels, and 3 quarters. There's our 3 and our 6 and our 8. So there's our 8 coins, and we want this one to be a quarter. And how many of those 8 are quarters? And they're 3. Now you won't have this obviously to write on, but you may want to write it on a piece of paper as you're doing your classwork. Now, is there any canceling? And actually, I'm not going to put approximate because I think this one's going to come out even. I'm going to reduce the 4/10, divide by 2. I'm going to reduce the 3/9, divide by 3. And then I can cancel this 3 and this 3. Any top, any bottom. I end up with 2 times 1 times 1. I end up with 5 times 1 times 8. So actually I could have canceled that 2 and 8. I forgot about that, but that's okay. 5 times 1 times 8 is 40. Now I can divide by 2 over 2. And when you divide 1/20th, you get exactly 0.05 is your decimal.